Here we're going to take a look at square root and cube root functions. Again, a lot more properties that go with these functions that we'll talk about later in the term, but right now focusing on key points that get us started with graphing these functions and the general shape so we can graph the transformations without knowing much more about these functions. So our first function here is the square root function. And what we look for is our square root symbol. So what we'll see here is that we're graphing just the square root of x. Our domain is going to start at 0 and go off to infinity, and the same is for our range. So let's see why that is. So if we wanted to graph some coordinates here, x and f of x, let's say I go -2, -1, 0, 1, 2, 3, 4. Let's go like that. So what we're going to do for this table is we're going to take the square root of the number on the left-hand side. So if I go and take the square root of -2, our issue is that we can't take a square root of a negative number. It's not real. So for a non-real number, we're just going to say that's undefined. Square root of -1, also undefined. Square root of 0 is just going to be 0. So that's where on our graph, any x values to the left of 0, we cannot graph. But we can graph this coordinate at 0. So that's going to be the starting point for our function. And then we're going to have the square root of 1, which is 1. And then we have a √2 and a √3, which we could get decimal approximations for those. I'm going to skip ahead to 4 because the square root of 4 is a nice number of 2. So when I'm graphing this function, I think of this coordinate 0, 0 to start, 1, 1, and 4, 2. That gives me a starting base for graphing this function here. But just notice compared to other functions we've graphed, it has a clear starting point. So we're not graphing any of the x values to the left, any y values below. Then for the cube root function, this is our cube root function. And you can see that with our cube root symbol here. So we have the 3 there along with the radical. This is going to have a domain of all real numbers and also a range of all real numbers. So this right here is our cube root graph. But again, let's go ahead and make a little table of values to see how this one is working. And I'm going to be pretty strategic with the numbers I pick. I'm going to go -8, -1, 0, 1, 8. So cube root of -8. And what we're asking here is a cube root of -8. We're asking what to the third power would give me a -8 out. So we're thinking of something that can multiply to itself 3 times to give us a -8, and that's going to be a -2. So a -2 cubed will give us a -8. And for -1, the cube root would be -1. 0, 0, 1, 1, 8, 2. So you can see -8, -2, -1, -1, 1, 1, 8, 2. So those are the key, and 0, 0. That's a good one to have in there too. So those are the key coordinates that I think about when graphing our cube root function. So let's go ahead and try this out with some graph transformations. So with this one, I see the cube root right there. So that's going to be our parent function. So if I needed a quick sketch, I go 0, 0, 1 away, 1 away, 8 away, 2 away. So those coordinates give me enough information to get started with my graph. And then from there, let's see, this 3 on the outside, that's going to be our vertical stretch by 3. The negative in here, that is going to be our reflection over y. And then the 4, that's going to be our horizontal. Remember, we use the reciprocal, so we're thinking 1/4 here. So that'll be a compression by 1/4. Okay, vertical stretch by 3. So we're still going to have 0, 0. But then we're always going up 1, I'm going to go up 3. whereas going up 2, I'm going to go up 6. So they just get multiplied. That stretches that out nicely. Let's see, 2, 4, 6. Okay. So there we are with that. Then let's do the reflection over y. So 0, 0 is still going to stay put. Before I had 1, 3, now it's going to be a negative 1, positive 3. And then 8, nope, yeah, 8 and positive 6 over here. And then same in the other direction. And 8, 2, 4, 6. Okay. There's our reflection over the y-axis. And last up, horizontal compression by a fourth. So we're still going to have 0, 0. 0, 0 is just going to move if we had a shift of some sort. Let's see, I'm focused on these green dots. So horizontally, I have a distance of 1 there. I want to change that to a fourth, which is very tricky there. What'll be easier to see is this distance of 8. Taking a fourth of that would now be a distance of 2. And same thing down here, a fourth and 2. So this really, really squishes in to something like, oh, this, roughly. And we could always graph more coordinates, but that's enough to get, we just need to see a few coordinates to get us going there. So that was a big one. Lots of transformations in there. As long as we track those coordinates, we're all good. Okay, with this one, I can see we have a square root. So for my parent function, I'm thinking of the square root. So I'm thinking 0, 0, 1, 1, 4, 2. I could even go out to 9, 3 if I wanted to. And then it only graphs on this side is what's key. Okay, so let's see. That 1/3 there, again, we're thinking reciprocal because it's inside the function, so it'll be a 3. So this will be a horizontal stretch by 3. And then with the -2, that's on the outside of the function, so that'll be our vertical change. So I'll be going down 2. Okay, horizontal stretch by 3. This will stay the same. Horizontal distance of 1 will change into a 3. Horizontal distance of 4 will now change to a 12, which is off the page. So I'll just estimate as best as I can if we're kind of out there. And that's all I can graph. So we'll have our function do that. And then we're going to go down 2 units, down 2 units, roughly down 2 units. And let's do that for our function with a clear starting point right there. Okay, so that's our square root and cube root functions and their transformations.